Hello, welcome back to another Voxel Heist tutorial episode, this one being called Unity Script Lifecycle and Component Interaction. Today we'll be looking at functions that are built into Unity called awake, start, update, FixedUpdate and LateUpdate. Now, I have gone over two of these, being start and update, but we'll look at them a bit more in depth. But first, we'll be looking at the task that was sent last episode, to where if we toggled is detected, that would change the current alert state. So, double click our script to load it up. And here you can see the script that I came up with. Something that I do like about coding is the fact that you can get the same result but code it different ways. Here is what I did. So I had our enum that was set up in the last episode, along with our alert state, and I just had an update so that whenever if is detected was true, the current alert state would be set to alerted. Otherwise, or else, it would be set to stealth, and it would then spam the debug. Like I said, today we'll be going through the different script lifecycle within Unity. So firstly, I'm going to head back over to Unity. I'm going to make a new script. This one I'm just going to make for an example. We'll call it Lifecycle debugger. So, as you can see, because we've made a new script, it populates it with the default void start and void update. We will remove these, but we'll type in void awake, and as you can see, it's already got the predictive text, so it knows that this is awake. Or it knows there is the function awake, I should say. Awake called, then do debug.log, start called, can then do debug.log update called, and we'll go into FixedUpdate, and last but not least, LateUpdate. So what I'm going to do is head back over to Unity. I'm going to disable our script called player controller for the moment and create an empty game object that I will set 0, 0, 0. Give it a cube just because I want it to look like it has some presence in the world. And on the game object, not the cube, so not on the cube which has the mesh renderer and things, on the game object I'm going to add the Lifecycle debugger. The reason I've disabled our player controller script is because it still has the update code on it. I don't want that to get mixed up with the output from our Lifecycle script. So when I press play, you can see that we have a lot of different logs being called. What I can do is press collapse, and this will merge all of the same debug.logs or anything in the console log, so we can see each unique thing more distinctly. So we can see that awake was being called first, and start was being called second. Awake is run just before start. Now, as I've said, it is the first frame start is run. Awake is the frame, I guess technically before, as it is when the game or script wakes up. You can also see that they're only being called once, whereas all of the updates are being run constantly. When start runs, all awake calls have finished. Update, as we know, it runs every frame. FixedUpdate is called at regular intervals, which is built into the Unity editor's time settings. As a default, it runs 50 calls per second. That is why we can see we only have 299 fixed updates called, whereas update called and LateUpdate is 983, because that's how many frames we've had. As I should be able to show you actually. In game, I can see stats. So if I press play, you can see that we're getting about 300 frames per second, which is a lot more calls than the 50 calls per second. And finally, LateUpdate is called after everything else, just as a result of it being the last update for that frame. But with that done, I can now show you as to why we'd use each one of these. So I'm going to go onto the game object. This is the empty one that we gave the cube and the lifecycle debugger to. I'm going to add a component. This one is called a Rigidbody. This allows us to apply physics to the game object. So I'll open up our lifecycle debugger again. I'll remove all of these except from awake. So for this test, I'm going to want to show how we can essentially grab our Rigidbody component so we can interact with it within our script. Rigidbody's good because then we can have physics-based movement within our game. So heading back over, I will first create a private variable, the thing that we want to obtain, so the component, which is a Rigidbody, and just as a shorthand I'll do RB for Rigidbody. Now in awake I can do RB, which is again the variable that we've set up over here, and I'm going to say this is equal to GetComponent Rigidbody. So what this function does is it will get the game object that this script is on. So heading to Unity, we can see that this script is on a game object which also has a Rigidbody on it. So this essentially looks at the game object, searches for the type we put in here. So for example, I could put anything or any component that could be on our game object. So I could do Lifecycle Debugger because this obviously is on. The error being just because it's expecting a Rigidbody. So I can do that. And of course, close brackets at the end because this is a function. And this returns a Rigidbody, the one that's on our game object. Debug.log. I'll say obtained Rigidbody. Save that. And head back over to Unity. If I press play, you can see that we've obtained the Rigidbody. But if I turn off the Lifecycle debugger, you'll see we still have the awake, even though the script's not active. So now I'm going to add another script, or another component, which we're able to do by, if we search for a component that doesn't exist, we can type in the name of our new script, click on new script, we can create an add-on, and we can just add it to the file. Once that's done, it will do the usual setting up the template script, and double clicking on it will bring us into the script. So I'm also going to show you how scripts can interact with each other. We're going to have our movement motor will have a public float speed of about 5. And on void start, we're going to just say that we've started our movement motor script. If I head back to the Lifecycle debugger, I can go to start, or I can create start and add a private movement motor. Again, that script that we just made, and I'll call it motor. And I'll say that motor is equal to GetComponent movement motor. The same thing as we did for the rigid body, because we know that this script is on the same as the movement motor script. Do debug.log obtained movement motor. So if I press play, you can see that we've obtained our rigid body, movement motor started, and we've obtained our movement motor. So in our lifecycle debugger, I'm going to add back the void update, and I will do this. If motor is not equal to null, then we can debug the motor speed plus the variable. So we're able to access the speed component that we had set up in the actual script because it's a public variable. So just to reiterate, in movement motor we have a public float called speed. We are getting the component of our movement motor script and assigning it to a variable called motor in our lifecycle debugger. We're then able to access all of the public variables from that script. As you can see, motor.speed. And if we play this, you can see that our speed is equal to 5, but if I increase it, you can see that the output changes alongside. So heading back over to our lifecycle debugger, I'm going to comment out this line because I like to keep it. However, I don't want it to run. Commenting is just 2 forward slashes at the start of the line. So heading back over to our movement motor script, I will add a few things to access the rigid body component. It's the same as we've done before, where we're setting a private variable called rigid body, making an awake function, and getting the component to assign it. Now in FixedUpdate, in FixedUpdate, I'm going to move our player character, or in this instance the cube, using the rigid body. FixedUpdate is good for this because it's very good at handling physics. So if you have any physics movement, it belongs in FixedUpdate, which is what we're doing. So we will run the built-in function move position, and I'll do the current position plus vector3 dot forward times speed time dot delta time. Oh, sorry, that would be fixed delta time. So to run through what this function does, I'll start with what's in the brackets. So this is the current position. rigidbody.position. Gets the position of the rigid body. Makes sense. We then add vector3.forward. Now, vector3.forward is a mathematical term within Unity. So a vector3 is a storage of 3 float numbers. So I can do new vector3 to show this off. So we can have, as the example had, it's 1, 2, and 3, but these are floats. So I can do 1.5, 1.2, and 1.6, but again, them all being floats need to be followed by an F. And that's all a vector3 is. It is storing 3 sets of numbers, which is very useful because, heading back to Unity, that is what our position, rotation, scale all take in. It takes in an X, Y, and Z. So these are all vector3s. So vector3.forward, if we can see, it is shorthand for writing vector3 0, 0, 1. So how that would translate to our game is increasing the z-axis. Or for the actual game object we'll be moving, it is this axis. And then by timesing by speed and timesing by fixed delta time. So timesing by our speed, this allows us to dictate how fast we would like it to move. And timesing by fixed delta time, as we'll see here, the interval in seconds of in-game time at which physics and other fixed frame rate updates are performed. So we're timesing by fixed delta time purely because it's a fixed update function. So if I save this, I can show you what it would currently do. You can see our cube moves off and falls off into the world because we're using gravity on our rigid body. So actually I will move them back a slight bit so you can sort of see them a bit clearly as they fall to the plane and then fall off the edge. I will actually interject onto a small thing called colliders quickly. So if I turn off this thing called a box collider, we should see that the cube just falls through the plane. So colliders within Unity are displayed by this green outline. You can see how it kind of brightens and darkens when I enable and disable it. Colliders set a boundary in the game object which do checks for collisions. So if I click on the plane, you can see that this has a mesh collider for a plane. If I did convex, you'll see it in a different detail, but it can show that it is there. So having colliders allows physics objects or even other objects to know if they're hitting something and stop them from continuing to pass through it. But with that said, I'm going to go back onto our game object and add another script. This one I'm going to call camera follow. And opening this up, we will now have a look at LateUpdate. So firstly, I need a public transform target. If you remember, a transform is this component that every game object has. It is the position, the rotation, and the scale of that game object. We're going to add an offset, just so we can tweak how far we want our camera to be away from the actual thing we're following, and a private void LateUpdate to do if target is equal to null. So null is a keyword within C#. It states if it is equal to nothing. So if target has not been set, then we will return. Return in this instance with nothing, because it's a void function, so it's not expecting anything to return. This just allows us to exit out of this function without continuing the rest of the code. But we'll just do transform.position, so we're getting the position part of the transform and setting that to the target position plus the offset that we will be setting. Apologies, I've put the camera follow script on the wrong game object. If we head over to main camera and add camera follow, we can set the object that we'd like to follow as our target or game object. And we'll say no, I'll keep it as is, I think. So we'll do 8, 10, minus 8. These numbers I'm getting from our current position. So in theory, when we press play, we follow the cube off of the edge. The reason we have camera follow running in LateUpdate is because, again, it runs after everything else, which is good because we're doing physics in FixedUpdate. If we were to run this within FixedUpdate, it could cause some jittery camera movements, which we don't want. We'd like the physics to have settled and then move the camera alongside it. So you might be wondering, why is it important to learn about all of the different life cycles within Unity? It is very, very helpful, as I've said, for physics, for doing updates that you want run slightly later, along with initializing scripts, so we make sure that they have their components before we try and access them. So for example, if I try to run this line of code in awake, it would never return correctly because we're not setting motor. In awake, we're setting after. And we'll be using quite a few of these things when we create our player controller script. Again, I've just been using this as a little playground to show all of these different mechanics within C#. But a player controller doesn't do everything. It just coordinates all of the different components. For example, when we set up the input that will allow us to actually control a player object, it just simply reads the inputs in update, and then in FixedUpdate it would then use those inputs to affect the rigid body of the player. But with that, I'm going to remove the camera follow from our main camera, go to the game object, and I think I'm going to remove the entire game object along with the scripts that we made. I'm holding down Shift so I can select multiple scripts at once, press delete, and we'll get this pop up in Visual Studio, but that's fine, we can just close these tabs and everything's back to normal. I'm now going to set up the task for this episode, back in a second. So, heading back over, I'll enable our player controller. This is the script that I've put the task within. I'm going to press play, making sure that my console is on collapse, and see that we get some random numbers. I like you to be able to have these random numbers come out in this order. I've added that for just a bit of, I guess, obfuscation, so to make it harder in terms of organising them. But it says as follows. So we have the first line printing out 5, the second line printing out 2, the line after that being 3, 4, and 1. You can use these numbers to try and remember of what only happens once, what happens multiple times, and what happens every now and then. But with that done, hopefully you'll be able to crack it, but we can see for next time. Speaking of which, now that we understand when Unity runs our code and how it can interact with different components, in the next episode we'll finally add player input using Unity's new input system. And I say new, it's been out for a bit, but we'll be using that system because the old one I believe is being depreciated, meaning that they're no longer going to be using it. But anyway, thanks for watching. Feel free to like and subscribe, and check out the Discord in the link below. Bye.